Tonight I'm going to do something different from what I usually do, namely making a little video of some repair, or rather some restoration of vintage equipment. But once in a while you have trouble with your working equipment, and that is exactly what I had or have. I was using my mini drill, which you see here, and it worked rather well until it suddenly gave out on me. And well, I was sort of disappointed by it because, well, it had cost me some money, and I could have taken it back to the shop in warranty and all, but the usual thing is, yes, they will give you warranty, and yes, they might even exchange it for a new apparatus, but most of the time what they tell you is we'll send it back to the factory for repair. And you know how that is. Repair always takes weeks and weeks before you get it back, and I just couldn't wait for weeks. Wait for several weeks until it came back repaired to me. So I decided that the only sensible thing to do with the mini drill is to take it apart and try to repair it myself, which I'll do right now. Now, I have to admit, I opened it once before I made this video, so I know more or less what to expect inside. You, of course, do not, so that's why I'm going to take apart the mini drill to show you what's inside and to repair it. Now, mind you, this repair is live in the sense that I do not know whether this part of the repair will succeed. Now, I think it will, so that's why I decided to make this video and make you share my experience. Okay, so this particular type of mini drill is a German make mini drill of the brand Mannesmann. And to take it apart, you need to take out 5 screws. Now, one of the screws is hidden under this label, this sticker. I guess they do that, as a sort of a check whether somebody worked on it or not themselves, because you have to pull loose the sticker, and once you do, it's quite visible somebody opened it. So there's really no way back. Now that I pulled away this sticker, I really have to go all the way on my own. Okay, so yes, I undid the center screw here. So now I need to undo these 2 screws here, and then these 2 screws by the drill head. So let's just do that. They are Phillips head screws, so you need a cross head screwdriver like this to undo them. So here we go. Now, what happened is that the mini drill, while I was drilling a particularly heavy piece of metal, just gave out on me. And I have to admit that while I was drilling, I felt that the body of the drill was kind of hot, yeah, or at least quite warm. So the reason why I thought maybe the engine, or well, I should say the motor, had given out because of the heat. I did expect somehow the electronics might play a role in the way that it did work or didn't work. So I'm going to unmount the whole damn thing and have a look at whether it was the motor or the electronics. So okay, now I've almost undone the body, so now I only need to move the cap. So here we go. You unbolt the head as you would if you would put a drill on. And now what you need to do is unscrew this black cap at the front. So here we go. Unscrew the cap. Okay, so now the whole body is loose. So technically I should be able to pull it loose from the whole lower part of the body, and there you go, it's loose. Okay, well, this is the inside of the mini drill. So now you see a small PCB mounted here, and on the PCB is a small electronic circuit which helps you to regulate the speed of this DC motor. And you regulate the turning speed of the motor by this little potentiometer here. So to undo I need to lift up the PCB. Unfortunately, it's held back by the screw here, this one here, and by the button. So the first thing I'll do now is undo the button, and you do that by simply slipping a flat screwdriver underneath and gently leverage it up like this. There you go. So okay, that takes care of that. And now I need to undo another Phillips screw here. To undo that screw. Okay, now I disconnect the switch from the power connector here, yeah, which is a type of connector like you see there. Don't ask me right away what the name of such a connector is, but it's very common. It's used in all sorts of electronic equipment. Okay, so I disconnect the switch from the power connector, and now I can probably lift up the whole assembly. Okay, here we go. Yeah. There you go. Okay, so we can put this to the side. And there you go. this is it. This is the whole assembly. Now, the thing is, the reason why it probably doesn't work anymore is because of this part here, which is the power transistor. So, the power transistor, I had a look at it, of course, is of the type TIP 127. And if I'm not mistaken, it's an NPN transistor. Now, it is driven through this operational amplifier, which you see here. Yeah, and this op-amp is of the type LM356. I had a look on the internet, and this op-amp really has two op-amps inside, but as far as I can tell, only one of the two op-amps is being used. And what it does really is it sends a small control current into the base of the power transistor, and by controlling the amount of current and of course also voltage that goes into the motor, you can influence the number of revolutions it turns per minute. So my first intuitive or my first intuition is that the power transistor just blew up, burned through. So what I did, I ordered a new TIP 127, and I'm going to unsolder the old TIP and solder back in a new one, and then see whether the whole thing works, yes or no. So let's go ahead and try it. Okay, so did I say that the power transistor is an NPN? No, of course it isn't. The TIP 127 is a PNP Darlington transistor. Now, the way you have to understand a Darlington transistor is really that one transistor is being driven by a second one here, like on the little schematic. Now, in fact, what this allows to is that it allows you to drive a power transistor with a very small current on its base. Because you see, the first transistor really functions as a kind of an amplifier, and thus enabling you to drive the second transistor, which is this one, with a tiny little current on its base, which is fine by me. It's also short protected by a diode, as you can see here. Now, this power transistor is rated for 5 amps and up to a maximum of 100 volts. So, technically speaking, that should work perfectly on this little DC motor which is in my mini drill. But apparently, well, you know, driving that little motor pushes up the temperature of the transistor all the way over its maximum junction temperature, which is 150 degrees Celsius, you see here. So you can imagine the amount of power that's being dissipated driving that little DC motor. So yeah, I think what happened was that the maximum temperature the transistor is built to withstand was well, overreached, and I think it only needs to be overreached by a maximum of 20 degrees C to make the transistor break down really quickly. So I mean in the order of minutes, and which is exactly what happened with my mini drill. Okay, so let's get back to my mini drill's PCB. Okay, well, I unsoldered the old TIP transistor, which you see here. So I unsoldered it from the PCB, and I already mounted the new TIP transistor inside the PCB, and I'm getting ready to solder it in. Now, you might wonder, how do I know that it's probably the transistor that broke down and not, for example, the chip or the motor for that matter? Well, I tested out the motor first by connecting it up to a DC source, which is this transformer. Well, it's actually a power adapter. Yeah, it outputs, let's see, 18 volts and 1 amp of power. Yeah, 1 amp of current and 18 volts of voltage. So I connected it up with crocodile leads to this motor, and the motor turned fine. But obviously it didn't work being connected to the PCB. So there you go, that's how I know it didn't work. So let's solder up the transistor first. Yeah. So here we go. You don't need to use huge amounts of solder. You just need to make sure the transistor makes good contact with the PCB. Okay, let me have a look. Okay, we're nearly there. But you have to try to make the solder contact as nice as possible, meaning that they should have a conical shape and they should flow nicely over the copper traces of the PCB. But since I'm nearsighted, it's kind of hard for me to tell. whether I'm doing a good job or not from close up and on such tiny parts, and I can see right now I'm not, so I need to correct that. And the way I do that is by using a solder pump like this and suck away the excess. Like that. See?
Well, if you continue with your infernal questioning, I have no reason to fight you, young man.
Okay, let's see. Okay, I need to correct that a little bit. There you go. Now I need to solder the wire back for the motor. Okay, perfect. Okay, that looks great. Well, let's give it a try, shall we? And see whether my repairs did what they needed to do. So let's connect up the power supply and see whether we can make the whole thing work. Okay, I connected up the power supply, so now let's connect up the whole thing. Yeah, and let's just have a look, whether we can make it work or not. Okay, here you go. Okay, now we connect up the power supply. And we'll see. Okay. I'll just hold the motor in my hand. So let's switch it on. Okay. It's switched on, so let's see whether it runs or not. Nope. No, it doesn't work. Let's try again. No, it doesn't seem to work. Although I can feel the motor trying to flip on, but it doesn't want to work. Okay, so back to square one. So what is the problem here? Well, if the power transistor, replacing the power transistor didn't do it, then there is another problem. Okay, well, I think the power transistor makes good contact. Still, I'm going to see whether Okay, I think that's okay. Okay. No. So replacing the power transistor didn't do it. So now we need to find out where another problem might be. Let's just do that. Okay, I found another problem on the PCB, which is that you can see here this small diode right here, which is a common type as far as I can tell. Well, it's a pretty small one, but I think you can see it. It's right here by the potentiometer. So this diode here was loose at one end, and I suspect that the current melted the solder at one point of the diode, which in turn, of course, made for a current interruption to the motor too. So it's quite possible that the whole PCB was actually starting to run hot. Also, well, I couldn't really notice it until I looked really close up, and I noticed that the solder on top, where the where one of the pins of the diode is soldered to the PCB, that the solder had just gone, was completely melted away. So, and I only noticed it when I started looking closely at the PCB with my magnifying glass. Now, honestly, we'll probably never know whether it was only the transistor that was bad, or whether this too posed a problem. But in any case, I restored this pin too, and in fact I'm going to touch it up a little bit. Yeah, like that. So now let's get ready and give it a try. So let me zoom out. Okay, here we go. I switch on the motor. Yep, and there you go. It runs. And as you can see, by turning the potentiometer, I can vary the speed with which the motor turns. So now it works again. So let's reassemble the whole thing and give it a final try. Reassembling the mini drill is really basically doing all the same things you did, but in reverse, while disassembling it. So let's just go ahead and do right just that. So So the first thing I did is put back the PCB and the motor in place, but for that I need to bend the transistor, the power transistor, flush with the PCB. So I'm going to do just that gently. Okay, so I bent the power transistor back on the piece towards the PCB. So now let's place it all back into the assembly. Okay, so you need to make sure the little ball bearing here is sitting correctly in its cradle. Okay, so let's give it a dab of lubricant while we're there. Not too much, but just enough to make it run smoothly. Okay, so now let's place back the PCB. Okay. Like this. Now I need to put back the screw which holds the PCB in place. Okay. Okie dokie. So now I need to reconnect the power plug. So you connect one here. One connection goes here, and the other one goes here, like this. Okay. So the next step is the release spring or the control spring. With this, what you can do by using this is really, you see the hole down the shaft here, yeah? And what you can do is block the shaft with this little pin sitting on top of a spring, yeah? By pushing on it, you can push the spring, you can push the pin into this hole and block the shaft, which allows you to unscrew or screw tighten the head of the gripping head, in which grips the spindle, or I should say the drill. Yeah, so let me show you. So you just put the spring back over the shaft like this, and you try to center it over the hole like I'm doing now. And what you do next is you, oh yeah, and I forgot one part. This, well, although this is not strictly necessary, I am going to put it back. This is a sort of a carrying ring, which allows you to hang up your mini drill from a hook, for example. So let's put that back too. Oh, hang on. Okay, so we're done. Yeah, there's quite a dramatic movie on telly, which is in the background, so don't pay too much attention to the background noise. Anyway, so you put back the cover on top like this, and you squeeze it together gently, so that you don't mash up any parts. Okay, hang on. I'm trying to make sure I...
It is a price I shall gladly pay.
Let's see. There's something blocking me. So let me see. So, you know, you don't want to squash any wires or anything. So, okay. And now you gently push it back into place. Okay, perfect. So now you screw back the end cap onto the assembly like this, just to keep it in place, you know. It also reinforces the housing exactly at the point where the ball bearing sits, yeah. So it relieves the housing from an excess of torque being put on it. Okay, so now the hook. Okay, so I place back the hook in the housing like this, and now I squeeze back gently the housing, and it should. There's something holding me back here. I have to be careful now not to break anything. Hang on. No, there's something holding me back. Okay, rather than forcing it, let's unmount it gently and have a look. Because you see, something is pushing me back, which is not a good thing. Something is pushing me back, and I need to figure out what it is. Okay. Ah, okay. So I got it right now, this time. So what was pushing me back was the power supply connector. So now that I pushed it back into its correct spot, I can indeed close the housing. So let's put back the hanging ring in the housing. There's still something pushing back. Okay. So, you know, I'm doing this live, so the troubles I'm having, you can see for yourself live. Okay. So the connector is correctly in its cradle. Okay. Let's see. There is something holding me back. So, but as far as I can tell, everything fits. Okay, and the wires don't block anything. Not that I can see. Okay, so technically it should just fit. I can't remember having it this much Play-Doh. Oh, okay. Maybe that is what's causing the trouble. Hang on. Okay, so it was the center screw after all that gave me some problems. So I retightened the center screw, okay, first. Okay, so now let's try it again to place the center, the end cap back like this. Nope, this is not good. Hang on. The center cap, the end cap has to be screwed on correctly, you see. Yeah, there you go. Okay, so I screwed back the end cap tightly. So now let me put back the hook ring. Yeah. I don't know how you call this exactly, but I would say it's a kind of a carrying hook. There you go. Hang on. Yeah, okay, it's in place. So now let's take the screws. Okay, let's put back the screws. Okay, there you go. No need to over tighten the screws, they just need to be tight and that's it. Yeah, because if you try to tighten them too hard, you'll over pull the threading in the plastic case, and then you'll be in a even bigger trouble. So don't over pull it, just screw it tight and leave it at that. Okay, the last screw goes in. Okay, it's not the most expensive mini drill around, but I would hate to have to throw it away, you know, because of a minor fault in its design. You know, reuse, repair, reuse, recycle is what I say. So there, I put now the head back, which holds the drill or any tool you want to insert into the mini drill's head, and let's tighten it up. Now, to tighten it up like this would be nigh impossible, because then it would simply turn and turn and turn and never allow you to tighten it up, you see. So I can keep on turning, nothing happens. So what you do by pushing this little button here is you actually push a little pin temporarily into the axis of the mini drill. So there you go, you push it in, you turn gently up, and now you see I can push it even deeper into the mini drill, and now I can tighten this head, you see, or release it, of course, like this. You see, now I can tighten it, but if I let go of the pin, then I can never tighten or untighten it. So that's the function of that little pin. Okay, so now I reassembled the whole mini drill. So let's just check whether it works or not. Okay, let me put back the little button on top of the potentiometer.
My home too. Kind of homecoming for you.
Okay, there you go. So it's on minimum right now. So let's switch it on.
They pass through here. Now they all sway over all the land.
Okay, it's switched on, as you can tell. And now let's turn up the speed potentiometer and see whether it works or not.
Who is this Malachi? The servant of the devil.
Yep. There you go. And this concludes the video of the repair of a Mannesmann mini drill. And it has no type, so we'll just let it at that. Mannesmann 18 volt 70 watt mini drill, and it works like new. So thanks for watching. Okay, so once in a while, when you're working on vintage equipment and all that, there comes a point where you need to de-rust stuff. So before I completely finish the Mannesmann repair video, I just wanted to tell you I found this de-ruster, which I think is probably quite similar to the Navy gel people in the USA use. So let's have a look at it. Okay, so I'm not... Oh yeah, okay, so instead of a nice pinkish orange color as in the States, this one has a greenish color, but it's a gel, and I'm convinced it does exactly what the Navy gel in the States does. So now I'm not being sponsored by this brand, I'm not endorsing specifically this brand, so I'm not going to say its name, but it starts with the name of this object, so I think you get the point. Anyway, you get about 225 mil for, I'd say in dollars it would cost about $14–15, which in euros is about 12 euros. It isn't really cheap, but I guess to de-rust certain sensitive parts on a chassis or something like that, I could use this gel to do the work. So yeah, there is in fact something like Navy gel available in Europe, only it still costs more than in the States, which is a shame really. But you know, that's part of the commercial trap we're in, where all things in Europe often cost a lot more than in the States. So anyway, I wanted to tell you, yes, there is something like Navy gel on the market here in Europe, only it costs more than in the States. And it has a different color, but I'm convinced it does the same thing as the good old Navy gel. So there you go, and this is really, truly the end of the Hammerite repair video. So stay tuned for more.